Let's get started. Hi, I'm Roshni Cooper. I am the Vice Chair of the Stanford IEEE branch, so welcome to our home turf. Thank you all for coming. I hope everyone enjoyed dinner. It's my honor to introduce our keynote speaker for the night, Diane Grunick. She is a senior research scholar here at Stanford. Diane began her career at Stanford also as an undergraduate, and then she went to law school at Georgetown, and since then has amassed nearly 4 decades of experience in energy, everything energy. So she's an expert in everything from energy policy to energy innovation, energy investments, so she knows a lot. One of her key claims to fame is serving as a commissioner for the California Public Utilities Commission from 2005 to 2010, where she led the way for energy efficiency and expanding the energy efficiency plan, and that resulted in a 3-year, $3.8 billion program, the largest in the U.S. It's a huge deal. And since then, after that, in May 2014, Diane began an appointment with Stanford University as a senior research scholar with the Precourt Energy Efficiency Center and the Schultz-Stevenson Energy Policy Task Force, which is focusing on, or helping Stanford have an increased focus on state and regional energy issues, and in particular on regulatory policy governance and the next generation of energy efficiency. Diane is also on the National External Advisory Committee of the National Renewable Energy Lab, and she previously served with the Department of Energy on the Electricity Advisory Committee, and she is a Department of Energy Clean Energy Education and Empowerment U.S. Ambassador. So we're very excited to have her. That was a lot of really fancy titles, so we're really lucky. And please join me in welcoming Diane.
Hi, so I'm very happy to be here, especially in an evening event. So thank you for giving your evening, not just to my talk, but then the session that we're going to be having afterwards. And you're probably wondering, given that this is a symposium, an event that's focused on basically participation with the electrical engineering profession, why somebody who is clearly not an electrical engineer, not a technical person, is talking to you. And it's to help you understand that in this whole evolving area of the smart grid, you can think of it as basically a shadow structure beyond all the physical issues that you deal with about thinking about what the smart grid physically looks like or how it would be designed, that there's this shadow structure of policymakers and regulators that have a very significant influence on what happens or doesn't happen. So I'm going to talk a bit about why policy regulators are even involved in this area. An interesting report that's been out called the Grid Modernization Index, which is sort of a quick snapshot of understanding what's going on, at least in the United States, and then talk about some of the issues of concerns to regulators in the smart grid development, some of the key activities going on in 2 of the leading states, California and New York, and then end up with just a couple of examples of areas that I've been focused on. So this is the overview that I just said that I would be talking about. And my first part is energy policymakers. So I'm going to assume, with a couple of exceptions from people I see in the audience that I know have been in the policy world, that you're really not familiar with this. And so again, I just wanted to lay some sort of a context. The first thing is, what is an energy policymaker when we use this term? And that's a shorthand for, here in the United States, with our 50 states, every single state has something called a Public Utilities Commission or a Public Service Commission. And that's the agency in California that I was a commissioner on for 6 years. And those commissions actually regulate what we call the investor-owned utilities. here in California, Northern California, the commonly known one is PG&E, Pacific Gas and Electric. You also have a separate class of utilities that are owned by their local governments, and a very common one in California is the Sacramento Municipal Utility District, Los Angeles Department of Water and Power. But at least in California, about 80% of the electricity comes from the investor-owned utilities. And around the United States, it varies how much, but suffice it to say that this is a very large structure that exists, with every state having its own PUC, and within those PUCs, for the most part, they're regulating the investor-owned utilities. So what do they do? This is sort of a snapshot. They set the rates. If you've ever paid your electric or natural gas bill, that's based upon rates that this little-known commission actually sets through a public setting. And the standard is they are to be just and reasonable, which you can imagine allows a lot of subjective judgment. They also are to be ensuring reliability. It's very important to keep the lights on, and in California we had unfortunate circumstance about, I don't know, many years ago, but not that long ago, where we didn't pay close enough attention, and we had blackouts, and it cost the state or everybody billions and billions of dollars. So it's a very serious role about ensuring that we have enough electricity so that we have a reliable and affordable system. Another very critical role is approving T&D expenditures, the transmission and distribution system. And for the smart grid, that's hugely important. And these typically are done through public proceedings where there's lots of information about what should what should the utility be building out over, somewhere between a 2, 3, 5-year period, and what are different alternatives, et cetera. But this is really the vehicle by which utilities then can include in their rates the necessary revenues that then they can make the expenditures to improve their systems. They also have, at least in California, the generation, the supply side, the power plants, that it's a very complex regulatory process that determines what is, quote, needed. That in some states, you do have a situation where the utility pretty much can decide what's needed and they build it. But because we've had some pretty significant instances around the country where utilities have built power plants that it turns out that they weren't needed, they weren't run as much, and this has ended up having a lot of cost to the ratepayers. California, at least, has a very complex and detailed system of determining need. And then for the most part in California, the utilities don't actually build the power plants, that they go out and do procurements, and then there's a whole industry of developers who develop the plants and then have long-term power purchase contracts with the utilities. And again, this is an area where those contracts are reviewed and approved by the commission, each and every one of them. A very big area here in California, but really around the country, is what we call the demand side. And that's what you can think of as energy efficiency and then demand response, where you're adjusting the peak load. Those are all programs that, one way or another, the commission sets what are the goals for the programs, oftentimes looks at the details of the program, and then authorizes the expenditures for the programs that the utility, again, can collect in rates and use it in implementing these programs. And they are very, very important here in California. And then overall, again, not just in California, but in states around the country where we're having a lot of movement towards clean energy, towards addressing the climate, the PUCs are a major, major entity for overseeing how that happens. As one example, in California, we have a renewable portfolio standard, which is a requirement for our utilities to go out and basically either build themselves or procure power for 33% of our electricity by 2020. And for the investor-owned utilities, again, this is a whole program that the PUC has set up and reviews the utilities' progress on it, and then tries to make sure that the costs under the program are reasonable. So that's just to give you a general overview of what a policymaker does. Now, when we think about the smart grid, the next question is, well, does any of this really translate to the smart grid? Or why are policymakers even interested in this? And so I put together a list of reasons why there's in California, but in a number of states now around the country, and certainly around the world, it's seen if we go about developing the smart grid in a sensible way, we can end up with some real benefits from the system we currently have. One is system reliability and resiliency, that generally with the smart grid you have more intelligence, you have more knowledge about what's going on in the physical aspect of the grid. And if that is done in a smart way, the belief is that that really can help on the reliability of the system. On the other hand, if we don't do it right, especially if we end up with a lot of distributed generation, a lot more reliance on demand response at the customer or building level, there's a concern, will we have that same reliability? So that's sort of, it could go either way, but it's seen overall it can help. It's also looked at with the smart grid that can really enhance our use of cleaner energy. That traditionally a power system is a large central station power plants, oftentimes fossil fire burning, coal, increasingly natural gas. We do have development of the large-scale renewables, but because of their intermittent power, you have to think about how other components of your grid can basically balance out the uneven fluctuations of the power. And so by combining a greater reliance upon the large-scale renewable with systems more at the customer or building level that deliver either battery storage or electric vehicles or distributed generation, the solar PV, overall, this is how we can transition our entire electric grid from one that has a lot of fossil-fired carbon emissions to one that can be quite cleaner in terms of carbon emissions. And again, this is where a lot of the policies that are being set are driving us, but it's seen that you need that backbone of a smart grid to be able to bring in all of these new technologies. Another one is this idea of the two-way flow, that in a traditional grid, as I said, it's a central system, transmission, substation, distribution going into our buildings, our homes and businesses. With the world that we're evolving, we have a lot of interest in solar panels. We have a very strong support program for that in California. We have a lot of interest in electric vehicles and demand response, energy efficiency. And so the term that is used is prosumers, that instead of just on the customer side of the meter that you're consuming the energy, you're also a way of producing energy that can flow back into the grid. And our traditional historical grid isn't built to be two ways, it's only one way. So some of the most interesting development is all the new technology and information, not just the physical technology, but the information overlay to allow the information and to allow both the power and information about that power to flow over from the customer side to the utility distribution grid. System-wide efficiency, it's believed, and I think this is true, by basically making your physical electric grid more intelligent, you have greater insight into how it is running, and you can really run things much more efficiently. Enabling the choice of technologies at the customer level. I've talked about the different technologies, and again, it allows us to have a much better understanding of the value that different types of customer-owned aspects of energy can provide value into the grid. I've talked about how it can help on increasing the integration of distributed energy resources, fuels, and resource diversity. And then this last one, market animation, is a really interesting area that we're looking at starting to be developed, is the idea that we can actually have markets down at the distribution level. That without spending too much time on this, at the transmission level, we have here in California and various places around the country entities that are called either independent system operators or regional transmission owners. And they basically run the transmission system either here in California within the state, though we're increasingly now starting to bring in some of our sister states, or you have in the Midwest a very large multi-state entity. And this is essentially operating wholesale power markets, where if you're a generator with a power supply, you can bid in to supply power. And in some instances, you can also actually bid in on the demand side as far as helping to balance the load. So what there is strong interest now in thinking about and seeing how we could develop it is, if you think about, we have all of these new supplies, whether it's actual generation or the ability to manage your load on the customer side, you can have entities that will aggregate that across customers, across businesses, across buildings, provide value back to the distribution and transmission grid in terms of, for example, firming the grid when we've got intermittent powers, helping on some of what we call the ancillary services. Right now, we don't have a system that values that or pays for it, because these types of capabilities never existed within the grid before. And so you can think about it that it's actually like a triangle, that part of the smart grid is technology, part of it is the policies that can support it, and then the third part are the actual markets that will essentially identify what value comes from these different ways of operating the grid or producing both demand and supply aspects that provide value, and then actually having a system of financial transactions to support that. So that's a very large area now becoming of interest. So you can think about, as we step back and look at the role of policy makers in the smart grid ecosystems, there's really three areas where all of this gets subsumed. The first one is just policies, setting policies. A lot of the way that things happen in the policy world is the agencies themselves say, we have a policy to develop this, or we have a policy to develop that. Then there's the investment side. Because the PUCs and PSCs regulate the utilities, as I said, they can set charges in rates. The utilities collect those rates, and that allows them to make the investments. And if you don't have that system, it's very rare that a utility is going to actually make an investment in a smart grid, because you can think about it. Otherwise, it has to come out of their shareholders, which because they're a regulated entity, for the most part, they want to see if it can actually be collected from rates from their customers. And then the other aspect is the actual operation of the smart grid, that regulators, for a host of reasons, as I've said, on reliability, on clean energy goals, on customer choice, they want to actually understand how the smart grid system is operating. So we don't have time to go into all of these, but you can think about on the policy level, I've just identified a couple ones where you may have setting of a renewable portfolio standard. You can, energy service providers is a broader term than just utilities, because we do have in California some variation on power being supplied by other than the utilities. But it's, for the most part, you can think of it like a utility. Requiring security and cybersecurity plans with the development of the smart grid. This again is an area that's just starting to be thought about. It's particularly difficult because your traditional PUC has no background expertise in cybersecurity per se, and so how you even think through what you would require from the utility and then analyze it is certainly a challenge that we see coming up. And metrics on how, what are the objectives of all these investments in the smart grid, and how can the regulators ensure that ratepayer money is being reasonably spent. On the investment side, it's just very important to have a way in which you can think about What are the investments that the utility will make? How are you going to review them? And then how's there going to be cost recovery? When I was a commissioner, I oversaw a number of the proceedings that were looking at the smart meters, the advanced metering infrastructure. This is an example where California has developed a policy now probably about 10 years old that it would have smart meters pretty much throughout the state, that we already had them with our largest customers, but the idea was that it would go down to the smallest commercial and then to the residential sector. Well, in order to do that, because the utilities are the vehicle for installing the smart meters, we had to have a proceeding in which the utilities came up with proposals to do it. They were then reviewed, a cost-benefit analysis was done, and then the utilities were able to recover those costs in their rates that paid for this, because I don't have the exact numbers, but I'm pretty sure, you know, it's probably somewhere between a $6 to $7 billion project statewide. And so this was a huge area of setting up, again, sort of the backbone that we needed with the smart meters to allow us to then really enable use of the smart grid. On the operations, I've talked about the advanced metering infrastructure and the deployment of advanced communications and sensors. So these are all aspects of areas of concern to the regulators. Now I want to move on to, in case you do ever want to sort of delve into and know what's going on, this is quite a good resource. That there's a nonprofit called the GridWise Alliance, and it has something called the Smart Grid Policy Center, and they decided a couple of years ago that they should do an annual state-by-state assessment of what was going on with the modernization of the grid. And so I was brought in to help them form an advisory group and then present this back to policymakers and others. And so this is basically, through a lot of research, it ranked and analyzed all 50 states and the District of Columbia based on policies, investments, and activities. And it's really trying to understand the relationship between these policies and these utility investments, and then how the customer itself is being engaged in this very complex world of the smart grid. And so we have put up there where you can get a copy of the report. It can be downloaded without charge. It basically looked in 3 areas: the state support through policies, customer engagement, and then grid operations, the investments that are actually being made to enhance technologies and capabilities. And this is just a quick snapshot. I fear that you cannot read the states, but this is the result from last year's report. The 2 leading states were Texas and California. And I actually felt that that was a great combination because they're 2 very different approaches to energy. That in Texas, they have deregulated the system. It's a very light touch on regulation. It's very much working on markets. California is sort of the opposite, that we have policies in every single area. We have a whole bunch of regulation. And yet we were able to determine that under both approaches, you can still have a lot of investment and a lot of development on this grid modernization. The other states, it was very interesting because it was a real mixture throughout the country. We've got Illinois, Pennsylvania, Maryland, Delaware, Nevada, District of Columbia, Arizona, Virginia. I don't know if I'll be able to see all of them. Idaho, Oklahoma, and Michigan. So we saw, this is the top 25%. We really did see a lot of movement around the country to make investments in the smart grid. So now I'm going to move on to what are issues of concern. Innovation is needed, and again, in this world, rarely do either utilities or policymakers want to start off with large-scale use of new technology. You almost always want to have pilots so you can test it out. It is a challenge then of basically moving from a pilot into a larger scale demonstration to full scale, in part because there is this risk of failure. I mean, it's inevitable with new technology, things will not work out as planned. The utility industry is very risk averse. It has not had much new innovation on the scale we're talking about. And so this isn't really an issue that has had to be faced on the level that it's faced. I mean, one example is PG&E put in smart meters, and for one reason or another, the technology that they chose didn't really provide the capabilities that were needed. And so they went in, and it wasn't the actual complete replacement of meters. With the advanced meters, it was putting on some additional technology. But they went in and they had to actually pull out some of the technology they had put in and put in replacement technology. I think this cost an extra $500 million. And I live in the PG&E service area, and I saw them come out the first time and give us a wonderful door hanger of here's all the things your meter can do. And then the next time, they didn't give a door hanger, but they did show up and literally took out equipment and put in new equipment. And this became very controversial as to, well, who should pay for that cost? Should it be the ratepayers of PG&E, or should it be their shareholders? Who should have seen what were the needs? A lot of investment is needed. As I've talked about, the way it happens is that with utilities, that gets put into rates. Utilities don't like raising rates, their regulators don't like raising rates, and believe me, the customers don't like it either. And so how this can be financed is a very, very big issue. And the utility business model is challenged, shall we say, and we don't have time to go into it, but basically you can think about it. If you've got all the customers owning lots of generation, PVs and solar, and they're also providing demand response or other services to the grid, the utility is not providing as much services as they did before. They're not making those types of large-scale investments that can go on the rate base and generate revenue. And they also have less throughput, literally, of the electrons they're providing. And most utility revenue models are based upon having lots of revenue. You sell more, you make more. This is a system which basically turns it on its head and says our entire approach is the utility is going to be selling far fewer electrons than they have in the past. And so this is a huge debate around the country. What are we going to do about the utility business model? What is the future of utilities? The rate designs themselves need to be changed. We, again, don't have time to go into it, but there's something called net energy metering, which is if you actually have distributed generation in your home or business and it supplies additional power when you don't need it, can you sell it back to the grid, back to the utility, and if so, what price are you going to pay? So this is, here in California, we're doing a major overhaul of our residential rates because the rate system was never set up to look and think about large-scale customer-owned or customer-leased generation and what that means for how rates are actually set. New rules for customer data access and privacy. All of those smart meters are collecting thousands and thousands of data points on what individual buildings are consuming. And who gets access to that data is a very, very large issue. The rule in California is that belongs to the customer. The customer owns its data, but the utility is essentially in trust keeping the data. And so there are lots of issues over who can have access to it. And then, as I've mentioned before, cybersecurity. In my mind, we haven't paid enough attention to this, but it's certainly very, very important with the much more granular system that we have with the smart grid. That also means we have many more points of entry into the system. So I'm going to quickly move into just an overview of California and New York. This is a lot of regulatory jargon, so I just wanted to put it out there. But the bottom line is that we have embarked upon a major review here in California, and literally on July 1st, the investor-owned utilities in California will be filing at the California Public Utilities Commission their plans for their distribution grid out through an 8 to 10 year period. And what's interesting is it's not just the physical plans, but it's really what type of planning and analytic tools they are planning to develop that helps them analyze what should be the capabilities of the smart grid, how should they deal with all these resources coming in on the distribution side, and what types of pilots do they envision doing over this multi-year period. So it's going to become one of the most closely watched developments around the country, just because this is California, and it also means literally billions and billions of dollars of investment that will be made. Then we have on the other side of the country another very large process going on by the state of New York and its Public Service Commission. And it's called Reforming the Energy Vision, or REV. This is a huge activity in the state of New York. They have in their proceedings over 200 different parties. They have, I was on a webinar on Friday, and they have, you know, somewhere between 8 or 10 very detailed technical groups trying to figure out what type of a system do they want with the distribution utilities? What does this mean in terms of technology that needs to be developed? And how is the role of the utilities going to change? And what type of investments are going to be needed, and what markets could be developed to really be able to enable those types of investments? And I've put up here the different policy outcomes that they're looking for, of which mirror what I had said at the beginning. And what they're doing in this very complicated public forum is trying to understand how different combinations between the policies, the technology, and the markets can optimize these various different outcomes that they want to achieve. And they're going to have their utilities file distribution system implementation plans the end of this year. These are the two major proceedings going on in the United States. So it's one of the times of the most innovation that we see coming on, and sort of the most thinking that's going to be going on as far as where do we want to go with these literally multi-billion-dollar investments. So I'll just quickly end with the project that I'm working on specifically here at Stanford is the Energy Efficiency Next Level project, and it's basically trying to think through, and this is part of the context of the smart grid, how can we really increase our use of energy efficiency? And we've got a draft report that we've released, challenges, opportunities, and new tools for the next level, and we'll be releasing it in a final report this summer. I have just two examples of where I see with the research and the report that I've been involved with, how it crosses over to some of the thinking on the smart grid, which is a little bit different than perhaps, you know, it's traditionally looked at. But this gets back to here in California, as I said, we have these smart meters that are generating an enormous amount of data. We have a number of private companies that have developed very sophisticated proprietary data analytics that literally can stream through and identify within a building, without going into the building, what are the various energy uses in the building, how does that building compare to other buildings, etc. And this is some work, this is a paper that I co-authored with the head of efficiency at LADWP, where it's trying to show how you can also use it for measurement and verification of energy efficiency savings on a level that we have never done before. That to the left, you can think about, you have 1 year's worth of data. This is just completely illustrative, but tells you at a very detailed level within an individual building what its usage is. The gray part is where, as a hypothetical, the building owner or operator did what we call an energy efficiency intervention. That, for example, maybe they tuned up systems that weren't working. Maybe they discovered that the energy management system was letting the lighting stay on weekends, you know, whatever. And the important thing is that because you've had a year's worth of very detailed data, you're able to develop a baseline, which is at the top of what would have been the usage if nothing had happened. And then you have down an ability to track the actual usage, and that difference is a much more granular understanding of energy efficiency savings in a building. And this is something that we literally could not have done 5 years ago. And it's because of the combination of the interval meter data with the actual ability to track continuing use. And some of the very interesting work is that the utilities are starting to take this information and aggregate it up so that when they're looking at their grid needs and grid operation, they really understand at a building level what is going on. My last slide is just some new work that's been done by PG&E, again using the meter data and the software analytics, where on the left you can see it's just, again, illustrative of how the analytics and the meter data help break down an understanding of what is energy usage within the building. And what they're discovering is that the traditional area that we've gone after in energy efficiency is what we call above code savings, whatever is the usage of a building above what's the current building code. But because most of our buildings in California were built before our codes came into effect, because we update them every 3 years, it turns out that we actually have this, the below code or the 2 code savings. What if we brought our buildings up to code? And then you can think about, we went beyond the code. And it turns out that our efficiency programs, for the most part, have been focusing only on the above code savings because we didn't have the analytical capabilities to be able to analyze within a building which part would be below code, which part would be above code, and then we have operational savings, which are basically being able to tune things up. And so now we're having a very large policy debate in California about, will we change the thrust of how we're approaching energy efficiency to basically be looking at the whole building savings and targeting those buildings that have the largest aggregate savings, as opposed to historically targeting just those buildings with the above code. So I wanted to just use this as an illustration of where we see the changes in technology intersecting now with what should be the policy decisions that we'll make. So that really was my quick run through the world of policy making in the smart grid. And if we have any time, I'll be happy to answer questions. Thank you. Sure.
I have a two-pronged question.
Okay.
One is that if we are going after the RPS targets and they keep moving up, with President Obama talking about 2035, 60+% renewable, why is there such a need for energy efficiency if we're going to move in that direction?
Was that just one? I have a second one coming.
Yeah. The second one is the public utility commissions only focus on investor-owned utilities. Munis have city governments that look after them. Co-ops have their boards that look after them. What can we do at the citizen level to create more alignment in their investment priorities across these three?
That one's a tough one. I mean, I'll just say, if it's a utility with the local government, it's, getting involved with that utility. Now, in California, most of our major policies are actually part of laws that are binding on our locally owned municipal utilities. For example, with the RPS, they're required to get to the 33% just as much as their own. But it really is, if they're controlled at the local level, it means, people who live there and businesses getting active. In answer to your first question, there's been a couple of studies done, and I'm going to put a plug in for those of you who are interested. At the on Monday afternoon, Stanford has the Energy Seminar, 4:15. At the June 1st seminar, I've got people coming from Lawrence Berkeley National Lab and a consulting company called E3, and they're going to be talking about the modeling that I'm going to very briefly review. So if you're interested in this question, they've done really state-of-the-art modeling. What they have done, and there have been other studies, they've looked at, in order for California to get to the deep emission reductions of 2050, because we have a climate change law in California, and it actually does say our goal is by 2050 we'll have reduced our 1990 carbon emissions to 90%, it's either 90 or 80% of the 1990 levels. Okay, and so what they've done is they modeled pathways to this, and they have reached a conclusion that three things have to be done. One is that you do all energy efficiency that you can do. The second one is you decarbonize your electric generation system in, from a carbon viewpoint, renewables, nuclear, if you have carbon capture and sequestration, but you have to shrink the emissions from the supply side from your electric grid. And then the third thing is you basically have to decarbonize your transportation sector. And that's really the tough one. The reason why you do energy efficiency in these models is you hit upon precisely an important point, which is if you're just reducing emissions, you could build all renewables and we could all have very, very inefficient buildings. But the economics don't work well. That they've done different scenarios, and basically you end up as an economy wasting a lot of money on electricity because even with the solar panels, there's still money being spent. But more importantly, you really need to just shrink the load, because at some point it does get quite expensive adding on more and more renewables. So it's really an economic driver if you think about deep carbon reductions.
And this is the case even in a distributed generation model with transactive energy and...
How this plays out, I don't know, but that's what it says, is that you will end up, as a society, as a state, we will end up spending far less money if we embrace energy efficiency than if we just do distributed generation renewables. Sure.
Yeah, Bergman and Finira, you beautifully illustrated the oxymoron between innovation and investor-owned utilities. I just had a great discussion with a Deloitte consultant a couple of days ago, so it's not coming from me, but I was trying to relay his thought, and I'd like your feedback on the idea that if the IOUs are building actually a venture fund to incubating innovative small startups. So I see a lot of grants going to those small companies called GE and Schneider and Siemens and ABB. They don't need that money. I do. So, so how would this work? I mean, is there a policy framework, legal framework where they could build a limited partnership on IOUs, or is this completely out of dreamland?
There's been a number of instances where in California, that's what I'm familiar with, the IOUs have actually done innovative partnerships, have sort of gotten into that whole innovation, technology innovation. For the most part, they actually did not do well because a utility is not, their mindset is not the same thing as an innovator. What we have as sort of a different way of looking at it now is we do have funds, I think it's about $250 million a year, I may be off by 100 million, that are small charges on the electric and natural gas rates that go towards basically R&D, not deep research. And it's the program is called EPIC. And the CPUC approves a 3-year plan, and then the California Energy Commission, which is another state agency, It oversees 80% of it, and the individual utilities do. And I can, at a break, give you information. And those are competitive processes where it's put out, here's proposals that we want in various areas, and there's some part that allows you to come in. So that's sort of a pot of money that is available, and you are then basically being paid either through the Energy Commission or through a utility. The utilities are also looking at proposals where they can invest in actual new technology. For the most part, it's proven technologies, because this is viewed as public money, and that it's not an appropriate use really to have a lot of risk here. And so it tends to be the view, if utilities can set up what are called unregulated affiliates, and they have, where that takes shareholder money and they go off and invest in it, and if they make money, that's great, and if they don't, the shareholders pay for it. And so that's really tends to be the view, that this ratepayer money, with the exception of this R&D fund, it's not really the right place to be using it.
Thank you.
Sure.
I noticed I'm in the wrong state. I'm moving here. Texas.
So one of your slides you showed was a bar graph in California and Texas.
Yeah.
The two top. So completely different. I mean, they have a competitive retail environment in Texas. Here we have a highly regulated environment. So what's the explanation? Why do these two totally different ones end up being the top ones? I understand Texas because I think it's market driven, and I think Reliant and the others there all are trying to do as much as they can to innovate and
well, one thing that is in common is both states have done very comprehensive investments in the smart meters. And so I think that unless you do that, you really haven't set up a framework. But other than that, it's just, you know, it shows you two different approaches. Well, there is in this index, frankly, I will apologize, I didn't go back and read it, but it gives the detail. There's, I think, 50 different questions that are asked and answered for the index for each of the states. So you can actually go in and look at the different ratings in these different areas for each of the states.
Okay. Thank you.
Okay. I guess maybe one more, and then it's you. You're the lucky guy.
All right. This will be a quick one. But you mentioned, and much has been made of elsewhere, this conflict between the growth in distributed generation and utilities' business model. For utilities that don't own their generation assets, whether they're procuring them via PPA or via centralized market, to what extent is that conflict really present if they're not actually long on the generation side?
Yeah.
There's two ways that I think about it. One is, if a utility owns its generation asset, then it can put those costs in what's called the rate base, and it can get a return on the basic physical plant. And we have in California moved away in large part from that being a major source of revenue to shareholders, because the utilities have pretty much gotten away from owning generation, or the plants are older and depreciated. So a lot of the investment in the actual technical side is on the transmission and distribution system. Those still can go in the rate base, and that's one reason why the utilities, frankly, were happy to put in smart meters, because it goes in the rate base and they have a return on it. But separately from that, there is a source of revenue from the utilities just selling power, okay, and having a pass-through of the power itself, in terms of then that utilizes the transmission and distribution system. And so you can think about, if you suddenly have a lot of people owning distributed generation, you can end up with stranded assets where you're not utilizing your transmission system as much as you had planned for. And so that's where they basically have seen what's called the death spiral of sort of from different ways it goes, the revenues go down. And then the third category is this net energy metering, which is basically, in California, the rule has been, for the most part, you can think about you sell the power back to the utility at your retail rate. The utilities say, well, that's not fair because if we were, why should we pay you the retail rate? We should only pay you the wholesale cost. And so then there's a big debate about, well, the utility, for the most part, still has to keep the distribution system running so that if you're distributed generation is no longer available, you can get the power, and those charges weren't set up to really cover the costs of the distribution system. I think Southern California Edison's monthly charge is 99 cents a month per customer. Well, that doesn't, and so that's the debate about how much do you raise those costs. But if you weren't to raise the costs, as again, in my example with Southern California Edison, they're just not getting enough revenue if you got a whole bunch of people in the distributed generation world, and they're only paying that 99 cents a month because the utility was relying upon revenue that it got from literally the transport of electrons to cover other costs.
Demand charges for residential customers. That's the answer.
Well, I'm not going to debate what it is. It's up. Okay, well, I guess that's it.
Thank you so much.
Sure.